Hello everyone, my name is Wu Chunling. I am from the Department of Rheumatology and Immunology in the First Hospital of China Medical University. I'm honored to give a talk on RA. Today, we particularly focus on the etiology, pathology, and pathogenesis of RA. First, let's see the etiology of RA. Until now, the etiology of RA is not very clear. Most of scientists agree that genetic and environment factors have a close relationship with the incidence of RA. Here, I will elaborate it from following three aspects. One is genetic considerations, the second is environmental factors, and the third is sex hormone. It has been recognized that genetic factors contribute to the occurrence of RA as well as to its severity. The likelihood that a first-degree relative of a patient will share the diagnosis of RA is 2 to 10 times greater than in the general population. However, which genetic plays a role in the causative mechanisms of RA? This is uncertain yet. Although twin studies imply that genetic factors may explain up to 60% of the occurrence of RA, the more commonly stated estimate falls in the range of 10 to 25%. The estimate of genetic influence may vary across studies due to gene-environmental interactions. The alleles known to confer the greatest risk of RA are located within the major histocompatibility complex. It has been estimated that 1/3 of the genetic risk for RA resides within this locus. Most of this risk is associated with allele variation in the HLA-DRB1 gene. It encodes the MHC2 base chain molecule. The HLA-DRB1 allele is associated with production of anti-CCP antibodies and worse disease outcomes. Furthermore, there is regional variation on the risk of disease. There are other associated genes. Among the best examples of the non-MHC genes contributing to the risk of RA is the gene encoding PTPN22. It varies in frequency among patients. It encodes lymphoid tyrosine phosphatase. This enzyme can regulate T and B cell function. PADI4 gene is another risk allele that encodes an enzyme involved in the conversion of arginine to citrulline and is postulated to play a role in the development of antibodies to CCP. A polymorphism in PAD14 has been associated with RA only in Asian populations. There are some other SNPs associated with RA, such as STAT4, CD244, etc. These genes participate in encoding proteins with various roles in B and T cell signaling. Then, let's see the environmental factors. In addition to genetic predisposition, a host of environmental factors have been implicated in the pathogenesis of RA. The most reducible of these environmental links is cigarette smoking. Numerous cohort and case-controlled studies have demonstrated that smoking confers a relative risk for developing RA of 1.5 to 3.5. In particular, women who smoke cigarettes have a nearly 2.5 times greater risk of RA, and this risk will persist even 15 years after smoking cessation. A twin who smokes will have a significantly higher risk for RA than his or her monozygotic co-twin. Moreover, the risk from smoking is almost exclusively related to RF and anti-CCP antibody-positive disease. In 1931, the sera from patients with RA were found to agglutinated strains of streptococci. After the discovery, researchers began to aggressively seek an infectious etiology for RA. Certain viruses such as EBV, mycoplasma, and parvovirus B19. EBV is ubiquitous and can persist for many years in the host. It also has a frequent association with ascites complaints. Titers of IgG antibodies against the EBV antigens in the peripheral blood and saliva are significantly higher in patients with RA than the general population. EBV DNA has also been found in synovial fluid and synovial cells of RA patients. So, these characters have garnered the most interest over the past 30 years. Sex hormone is also related to RA. Men and postmenopausal women with RA have lower marrow serum testosterone, LH and DHEA levels than control populations. It has been hypothesized that hypoandrogenism may play a role in the pathogenesis of RA or arise as a consequence of chronic inflammatory response. RA occurs more commonly in females than in males. Up to 75% of female RA patients will note overall improvement in symptoms during pregnancy, but often will flare after delivery. Such indicates the role of estrogen in the disease pathogenesis. Next, I'd like to share the pathology of RA with all of you. RA affects the synovial tissue and underlying cartilage and bone. The synovial membrane normally is a thin layer of connective tissue. It covers most articular surface, tendons, shells, and bursa. The pathogenetic hallmarks of RA are synovial inflammation and proliferation, focal bone erosions, and thinner of cartilage, articular cartilage. Chronic inflammation leads to synovial lining hyperplasia and the formation of panels. It is a thickened cellular membrane containing fibroblasts-like synovial cells and granulation reactive fibrovascular tissue that invades the underlying cartilage and bone. In inflammatory infields is made up of no less than 6 cell types: T cell, B cell, plasma cells, dendritic cells, mast cell, and granular cells. The T cells comprise 30 to 50 of the infiltrate, with the other cells accounting for the remainder. In some cases, the B cells, T cells, and dendritic cells may form higher levels of organization, such as lymphoid follicles and germoscentol-like structures. Synovial fibroblasts and macrophages secrete lots of growth factors. They promote the formation of new blood vessels in the synovial sublining. The structural damage to the mineralized cartilage and the subchondral bone is mediated by the osteoclasts. Osteoclasts are multinuclear joint cells and appear at the penis-bone interface. They can be identified by their expression of CD68, tartrate-resistant acid phosphatase, caspin K, and the calcinin receptor. These lesions typically localize where the synovial membrane inserts into the peripheral surface at the edge of bones close to the rim of articular cartilage, and at the attachment sites of ligaments and tendon shells. Another form of bone loss is periarticular osteopenia. It occurs in joints with active inflammation, and it likely results from inflammation of bone marrow cavity. These lesions can be visualized on MRI scans. Generalized osteoporosis is a third form of bone loss found in patients with RA. It results in the thinning of trabecular bone throughout the body. Articular cartilage is now known to be a highly responsive tissue that reacts to inflammatory mediators and mechanical factors, which in turn alter the balance between cartilage anabolism and catabolism. In RA, the initial areas of cartilage degradation are juxtaposed to the synovial panels. The cartilage matrix is characterized by a generalized loss of proteoglycan, most evident in the superficial zones adjacent to the synovial fluid. Degradation of cartilage may also take place in the perichondrocytic zone and in regions adjacent to the subchondral bone. Let's see the pathogenesis. The pathogenesis for RA is a complex interplay of genetic, environmental, and immunological factors. And dysregulation of the immune system and a breakdown in self-tolerance occur in the patients with RA. In summary, the genetic environmental factors and sex hormone are associated with RA. The synovial inflammation is the basic pathologic hallmark. Dysregulation of the immune system and a breakdown in self-tolerance play a great role in the pathogenesis of RA. That's for today. Thanks for your attention.